All right, last call for those of you that do not want to be in the video. Please make sure that you turn your cameras off. Can you hit the continue button up there, Jose? Jose, get your foot down. He ain't at your house. Thank you. All right. Okay, good people. I'm going to go ahead and share my screen. All right, this is the main screen. We're in week 8. Our digital interactive notebook. I'm going to extend the deadline because this week I just want you to focus on, studying. So you can turn your digital interactive notebook in on Monday. If you need additional help, please do not hesitate to ask for help. Yes, baby. When he comes back? Yes, sure can. All right, so your digital interactive notebook is due Friday, but you can turn it in on Monday. Okay, no late penalties as usual. Just make sure that you get that digital interactive notebook turned in. Extra credit grade is the iReady. The second iReady project is for extra credit. Some of us already did it and I already added your extra credit points, which is amazing. But if you need that extra credit push, please don't hesitate to do project 2 for extra credit, okay? We are on our EOC review. This is week 8. And even if you click on week 8, it's going to take you right to your EOC review. We only have 2 more days, today and tomorrow. You can meet with me on Wednesday if you want to, if you need extra help, but we only have two days to review. Okay, so this is where we are. Geometry. This is where we are right now. So the geometry, I want you, if you haven't done the geometry, we're going to do geometry tomorrow. We're going to skip down and do quadratics today so I can finish that last video and then put it on our page. So let's go ahead and take out your quadratics, notes, notebook, and your sheet. And it looks like this. For those of you that are in the classroom, I printed that out for you. It looks like this. Yep. This is EOC review number 8. I'm going to open this up so you can see exactly what it looks like. If you're at home, please open this up. I'll show our work for credit. Yes, baby. I don't see you. Okay. Say again, baby. You need one? You need number 5? Okay. Just remind me when we get finished with this one to print number 5 for you, okay? This is where we're at. We're doing quadratic functions. This is the last one. Well, tomorrow we'll do geometry, but if you want to go ahead and do geometry tonight, you can. That video is already there. Please make sure that you watch the videos in order. Watch the first video first and the second video second. All right, use the raise your hand tool if you're at home. If you're not ready, you need a little time. In the classroom, if you're not ready, please raise your hand. All right, I don't see any hand raises. I'm going to the dot camera. Please make sure that you show your work. Please also ask questions if you have them. You will probably need scrap paper because it may not be enough space here to actually write everything down. If you use scrap paper, please make sure that you submit it with the work, okay, so you can get 100% credit, okay? And I already have my scrap paper. All right, here we go. Okay, just a quick review. Remember, when we're dealing with quadratic word problems, the word problems are talking about downward parabolas. Okay, we use the standard form for quadratic functions is this, where your A is the downward velocity or downward speed. which is always going to be, if it's real life, real world situation on Earth, it's always going to be negative 16 x squared. That's going to be this part. Okay, if A is positive, it's upward parabola. If A is negative, such as this, it's a downward parabola. Your B is your starting or your initial speed or velocity. Let me put starting. Your starting speed or your starting velocity. Okay. And your C is going to be your starting amount, your starting height. Okay. So this is your shift up and down. This is where the line, where the U crosses the y-axis. This is your starting height. This is where it crosses the y-axis. Any questions about what A, B, and C mean in a quadratic function? Of course, your B is going to shift it from left to right. This is going to either make it go upward or downward. In a real life situation, it's going to be your downward velocity. And this number on the end that has no variable attached to it is your starting height. It's your starting amount. This is where the parabola crosses the y-axis. Ladies, y'all focus, okay? Did y'all understand what I said? Are you sure? You okay? Okay. All right, good deal. If you have questions, just stop me. Don't hesitate to stop me, okay? All right, let's keep going. All right, this one right here, it says this function, and notice how there's a negative in front, so that means we're talking about a downward parabola, models the approximate height. So y is your total height of an object in t seconds. So x is seconds, okay, after it is launched. So it looks like this. I can already tell you that, look at this right here. This is my initial speed, and this is my starting height. I can already tell you that's what it is, okay? How many seconds does it take for the object to hit the ground? So in my parabola, this is what I'm looking for. I'm looking for this right here, when it hits the ground. In my U shape, I'm looking for this right here, where it hits the ground. And I know my height is going to be 0, but how long is it going to take? What is my X value here? My Y, of course, is 0, but how long does it take for my height to be at 0, for it to hit the ground? This is what I'm looking for. So in order to figure out what my zeros are, look at this, it's calculated inactive. I have to factor this out and set each factor equal to 0. So that's how if I don't have my calculator to figure out what this is going to be, I have to factor this quadratic function out. So I'm going to use I might have enough space here. I'm going to rewrite. And I'm going to factor this. When I factor the equation or the quadratic function, I always look for GCF first, okay? What's the GCF of all 3 terms? What do they all have in common? What's the greatest common factor that they have? Yes, 5 is. So I'm going to take out a 5, okay? So when I take out a 5, what can I multiply times this 5 to give me a negative t squared? And while we're at it, honestly, because it's a negative number, we need that first number is a negative. We need to take out the negative, okay? That's going to save us a lot of drama in the end. So let's take out a negative. So what can I multiply times this negative 5 to give me a negative 5t squared? Somebody? T squared, good job. Okay. What can I multiply times this negative 5 to give me a positive 20t? Negative 4. Okay, don't forget the t. Good job. And what can I multiply times this negative 5 to give me a positive 60? Say again. negative 20. Okay. Negative 12. Why I say 20? That's 100. Okay. Any questions about doing GCF? All right, so now after we do GCF, we need to factor what's in this parentheses here. Notice how this first number, this A value is a 1. So we're going to have 2 binomials, okay? And keep bringing down this negative 5. Don't even worry about it. Just keep bringing it down. What are we going to put in each parentheses here? Does anybody remember? T. Very good. T here and T here. Excellent job. Because T times T is going to give me this T squared. Now I'm going to draw a table. Okay, I'm going to draw my table over here. Okay. I'm going to look for 2 numbers when multiplied together, give me a negative. Negative 12. Move this out the way. But when I add them together, I get a middle number of a negative 4. Sum is negative 4. Okay, so let's think about it. What 2 numbers can be multiplied together to give me a negative 12, but when I add them together, I get a negative 4? Yes. Negative 6 and 2. Sure. Thank you for telling me. Okay. So when I add those together, negative 6 plus 2, that gives me a negative 4. So I can use negative 6 and positive 2. So I'm putting negative 6 here, plus 2 here. Oops, sorry, y'all. Okay. So now to solve, to figure out where the parabola crosses the x-axis, I'm going to set each of these equal to 0. Okay. So I got negative 5 equals to 0. We all know this is not true. That's irrelevant. Okay. We're going to set t minus 6 is equal to 0 and solve. Then we're going to say t plus 2 is equal to 0 and solve. Anybody lost so far? Okay. All right. So now how do we solve for t? How do we get t by itself here? What are we going to do? Add 6 to both sides. Good job. This is going to give me t is equal to 6. Okay. Now how do we get t by itself here? Minus 2. So this is going to be t is equal to a negative 2 here. So which one makes logical sense? If t is seconds, which is going to be my answer here? Is it going to be positive 6 seconds or is it going to be negative 2 seconds? The 6 seconds. This is going to be my answer. This is a part of the parabola that actually makes sense. This is going to be 6. Over here would have been negative 2. This is not a practical domain. That doesn't even make sense as it pertains to the problem. My answer has to be a positive number. Any questions about how I get positive 6 is my answer? Okay, let's look at number 2. Let some more folks in. Okay, what is the smallest of 3 consecutive? Consecutive means numbers that are back to back. Okay, positive integers. If the product of the smaller 2 integers is 5 less than 5 times the larger integer. You have to do one piece at a time, okay? So let's focus on the first sentence. It said, or the first part of that sentence. What is the 3 consecutive positive integers? So we got x is the first number. Then right after that, x plus 1 is going to be the second number. Okay, because if x is 2, then the next number will be 2 plus 1. Then the next number will be 2 plus 2, well, whatever, x plus 2. This is my third number. So this is how you write consecutive numbers that you don't know. You don't know what they are. Any questions so far? Okay, that's the first part of it. If the product of the smaller two integers, so these are the smaller two. Okay, so that means product means you add those together. So that's x times x plus 1. Some more folks in. So the product of the smaller two integers that's equal to 5, we're using the words, less than 5 times the larger number. Okay, so when we use the words less than, the order reverses. Remember, subtraction, but the order reverses. It's 5 less than 5 times the larger integer. The larger integer is x plus 2 minus 5 because it's 5 less than. So the order reverses. Any questions about how I wrote that? Okay, so now I have to solve. So please watch how I solve this, okay? So the first thing that I'm going to do is simplify each side separately. So I'm going to do distributive property over here. So this is x times x, and then x times 1. So this gives me x times x, which is x squared, and x times the 1, which is plus 1x. Any questions about that side? Okay. This side, we're going to use distributive property. Okay. Here we have 5 times x is 5x. 5 times the 2 is 10. Bring down the minus 5. Are we okay? Okay. Now, when we do this, we are going to combine like terms. We can't combine these terms because they don't have the same exponent attached, so don't do that. But here, we can combine these two. So we got x squared plus x is equal to, and when we combine this together, this gives me a positive 5. Any questions about that line? Okay. Keegan, you good? Are you good? Okay. So now what we're going to do is move the variables to the same side, okay? We're going to move everything over here, okay? Because in order, I already know this is a quadratic function. I already know that. So I'm going to move all the variables to the same side. I don't want nothing on this side. This side is going to be equal to 0. So I'm going to move everything over here so that I can factor. I'll probably do that part on a separate sheet of paper to solve a quadratic function. The only way to solve a quadratic function without the use of the calculator is to factor it, just like we did above. So I'm move everything to the same side so I can factor it like I did up here. So I'm going to move this over here by subtracting 5x first. I can only subtract 5x from 1x, and that's going to bring down this x squared. This is going to give me a negative 4x. This is gone. Now I'm going to move the 5 over here. So I'm going to subtract 5. I could have moved them both at the same time if I knew what I was doing, okay? I just didn't want to rush it for you just in case you still didn't know. None of these terms are alike. So what I have is x squared minus 4x minus 5. And on this side, I get 0. Now I'm ready to solve this quadratic function. How do you know, Ms. Reyes, this is a quadratic function? Because there's an x squared term. Any questions about that? I might have enough space to factor here. So let's rewrite this. X squared minus. Now I have to factor it to solve it, just like I did in the problem above. Okay, so this first number is a 1. There's a GCF, no GCF here. So we got 2 parentheses since this first term is a 1. We're going to put x in each. I'm gonna do my table out to the side. I'm gonna do it over here so I have some space. Oh, it's more people coming in. So here, this back number is a -5. So I'm gonna think what two numbers can be multiplied to give me a -5, but when I add them together, I get a -4. Anybody? Yes. Very good. -5 times a +1. So when I add them together, -5 plus a +1, I do get a -4. Great job. So the two numbers I'm going to use is -5 and +1. So this is -5 and +1. Any questions about how I factor? Now remember, I have to solve. I have to figure out what the x values are, okay? Yeah. So I'm going to set each of these equal to 0. Okay. So how do I get x by itself here? What am I going to do to get x by itself? Yes. You're going to add 5 to both sides here. This gives me x is equal to 5. Okay. And here I subtract 1 here. This gives me x is equal to what? -1. So which one of these makes logical sense if they're supposed to be positive integers? 5. So 5 is going to be the first number. What's going to be the second number? 6. What's going to be the third number? 7. But they're looking for the smaller one, which the answer is 5. Okay. Any questions? Please use the raise your hand tool if you're at home and you're still copying, so I'll know. If you're in the classroom and you're still copying, just raise your hand. If you have any questions, please let me know. Nobody is still copying. Are there any questions? Okay, moving on to the next one. Okay, so the next one is the larger of the right triangle is 3 centimeters longer than the smaller leg. Okay, so we're talking about a right triangle. So just draw the right triangle, please. Right triangle looks like this. Okay. And we got the longer leg. There are 2 legs. Let's go with the longer one, which is this one. The longer leg, this one right here, is 3 centimeters longer than the short leg. So let's label them. This is my A, my B, and my C. Since it's a right triangle, I think Pythagorean theorem, A squared plus B squared equals C squared. You can only use Pythagorean theorem with right triangles. The A and your B are your legs. The C, the side opposite of the right angle, is your hypotenuse. That's how you label your triangle. The longer leg, we're choosing this one to be a longer leg, is, so that's A, is equal to 3 centimeters longer than the smaller. So that's 3 plus B. Okay. The hypotenuse, this is the hypotenuse, is equal to 6 centimeters longer than the smaller one. Okay, so this is going to be 6 centimeters longer than the smaller leg. So this is going to be smaller leg plus 6, or other way around, doesn't matter. 6 plus smaller leg. Oh, smaller leg is B, isn't it? Sorry. This we said was the smaller one. All right. So how many centimeters is or how many centimeters long is the smaller leg? This one right here. So we're going to use the Pythagorean theorem to figure that out. Okay, we're going to substitute the information that we know. All right, so we have a squared plus b squared equals c squared. So this is our a, and this is our c. So we got a is 3 plus b, and we got b squared. We got c is b plus 6. I'm gonna use paper. I'm gonna use some paper out to the side. Okay. All right. So here I'm gonna do this first, which is 3 plus b times 3 plus b. I'll do this part first. Okay. So this is going to give me, when I multiply, I'm gonna do distributive property twice. 3 times, ooh, sorry y'all, 3 plus b, and then b times 3 plus b. I'm doing distributive property twice and combine like terms. Okay, so here we go. We got 3 times 3 is 9. 3 times b is 3b. Let me do b. b times 3 is 3b. b times b is b to the second power. We combine like terms, so this gives us 6b. Bring down the 9 and bring down the b squared. And I'm gonna put this in order. This is gonna be b squared plus 6b plus 9. Okay, I'm gonna stop there. Are there any questions about how I multiplied? See a couple people still writing, so I'm gonna pause for the calls. On problems as such, just take your time. You do have plenty of time to work out. You will have plenty of time to work out problems. Do not rush it, but just don't spend so long because you lose your momentum. Any questions about how I multiplied this? Okay, so I've done this part. You see, I've already done this. So I'm gonna rewrite this as b squared plus 6b plus 9. I did this, okay? So now I'm gonna bring down the plus b squared. So now I'm gonna do this. This is b plus 6 times b plus 6. I wish I would have told you how to do full. Full would have been so much shorter than this, but we just didn't have the time. All right, distributive property twice again. So this is b times b plus 6, and then plus 6 times b plus 6. We're doing distributive property twice. Distribute, and combine like terms. So let's multiply. Okay. So we got b times b is b squared. Then we got b times 6 is 6b. We got b times 6, so 6 times b is 6b. And we got 6 times 6 is 36. Okay. Please let me know if you get lost anywhere. I'll be more than happy to stop. Hunter, you okay? Do you understand? Do you understand? Okay. Combine like terms. These are the terms that you're going to combine here because these are the only two that are alike. Bring this down. This is going to be plus 12b plus 36. Okay. So we're going to write that here. Okay. Now we're going to combine. We're going to combine like terms. So here when we combine these terms right here, 1b squared plus 1b squared is 2b squared. Bring everything else down. I combine these two. Now, you know this is a quadratic function, so you're going to move everything to the same side and factor. Okay, this one's a lot of work. So we're going to subtract all of these and put it over here. So let's subtract this b squared, and I'm going to do all of this at the same time. So I don't want to take up all this space. Okay, so I'm going to subtract this one. So 1 in front of it. I'm going to subtract this one from this, minus 12b, and I'm going to subtract this, minus 36. Okay? And nothing should be left over here, just 0. All right, so let's subtract. Here, when I subtract this, I'm going to get 1b squared. When I say 6 minus the 12b, or 6b minus the 12b, that's negative 6b. And then when I subtract this, what's 9 minus the 36? This gives me a negative what? Yes, 27. So now we can factor this.
I'm not sure I understand. Is there something else I can help with?
You wasn't trying to help me earlier. Sorry. All right. Here we're going to do b squared minus 6b minus 27. So you're factoring again. Do the same thing we did before. We got 2 parentheses. We already looked. This does not have a greatest common factor. We put b here and b here. When you do your table, what two numbers can be multiplied to give me a negative 27? But when I add those two, and when I add those two numbers together, they give me a sum of a negative 6. 9, negative 9, and positive 3. Very good. Negative 9 plus 3 gives me a negative 6. So I'm going to use minus 9 and plus 3. To solve, I'm going to set them both equal to each other. Not equal to each other, both equal to 0. Okay. So when I solve this, what do I get? How do I get b by itself? Add 9 to both sides. This gives me b is equal to 9. And here, subtract 3. This gives me b is equal to a negative 3. Now, which one of these answers makes sense? The 9, because it's positive. Okay. So the shorter leg is going to be 9 centimeters. Any questions about how I got 9? Some of these problems are gonna be really, that's just what they do, especially the calculator inactive. They like to punish y'all a little bit. Please make sure that you understood what I did. And again, you can always go back and watch the video. All right, number 4, this is a shorter problem. It says which term is a factor? So here's 2 terms, so we're just doing GCF for ones that look like this. So what's the greatest common factor? What can I take out of both of these? 3a, just the 3a. And what would be left? What can I multiply 3a to get 3a squared? A here plus, what would I multiply to get 12a here? 4. So these are my 2 factors. Which one of those factors are actually there? The 3a is there. This one I don't see. One or the other is going to be there, not both. One or the other is going to be there, not both. Any questions about number 4? Okay. Raise your hand if you need more time. All right. Number 5, it says which graph, and this is still calculated inactive, so keep this in mind. That's why you don't see me picking up a calculator yet. Which graph displays this function, this equation right here? So in order to figure that out, you've got to multiply this to see what this actual quadratic function is going to be, okay? Or you can set it equal, you can set both of these equal to 0 to see where it would cross the x-axis. You can do that too. So if I have 2x plus 3 is equal to 0, how do I get x by itself? What do I have to do first? I can subtract 3 on both sides. This gives me, this is gone, this gives me 2x is equal to a negative 3. Then I'm going to divide by 2, and that gives me x is equal to a negative 1 point what? 1.5. So that's where it would cross at negative 1.5. Let's look at the other one where it would cross. X minus the 2 is equal to 0. Okay, so it's going to cross here. And let's find another place where it's crossing. Let's add 2 to both sides. This gives me x is equal to 2. So it's going to cross at these 2 places. So let's look at our graphs to see. Okay, look at your x-axis. This is at negative 2, and this is at positive 1.5. So A is not my answer. Okay, let's look at B. This is at negative 1.5, sorry. So that's good. And this is at positive 2. So B is my answer here. Okay. Any questions about that? This parabola is going upward, okay, because A is a positive number. These are all positive numbers. A is a positive number, so that's why it's this one and not this one. Any questions about how we get B as our answer? Okay. All right, let's look at number 6. Number 6, the floor of a rectangular cage, so we're going to draw a rectangle, has a length of 4 feet greater than the width. So length is 4 feet greater than the width. So that's width plus 4. Okay, this is W. This is my width. James will increase both dimensions of the floor by 2. So that means you're going to add 2 to each of these. So I'm going to add 2 to this one. Oops, sorry. I just went on and added it. I'm going to add 2 to this and 2 to this. Okay. Which equation represents the area? So area of a rectangle is length times width. Any questions so far? So we're going to multiply. My length, let's combine these, this is 6, right? So my length is going to be W plus 6. And my width is going to be W plus 2. Any questions about how I got that? So now I'm going to multiply I'm gonna do distributive property twice. So we have W times what's in this parentheses, W plus 2. Then we have plus 6 times what's in the parentheses, W plus 2. And we're going to combine like terms. We're going to multiply and combine like terms. So this is W times W, and then W times 2. So this is W squared plus 2W. This is positive 6 times W and positive 6 times 2. So this is 6W plus 12. So now you're going to combine the terms that are alike, the two terms in the middle, which is going to give you 8W. So this is W squared plus 8W plus 12. This is your area. Answer choice there is going to be D. Any questions about that? Okay. All right, number 7. This is difference of squares here. They're both perfect squares. 1 is a perfect square. Remember, the square root of 1 is equal to 1. The square root of 36 is equal to 6. These are both perfect squares. So here, excuse me. So when you have difference of squares, you have two parentheses. You're going to put T here and T here. The square root of 36 is 6, so you have 6 here and 6 here. In order to multiply and get a negative 36, one has to be a positive and the other has to be a negative. It doesn't matter which one comes first. So your answer here is going to be B. Why not D? Because this is perfect. These are difference of squares. And so the square root of 36 is 6. So you have to put 6 in one and 6 in the other. Do you understand that? Okay. That's a good question, what you said, though. So you would do the same thing if it was T squared minus 25, because these are perfect squares. The square root of 25 is 5. Okay. All right. Let's look at this one. Number 8. It says which function, this equation, which one of these is the graph? And remember, it's calculated inactive. So this is how you do that. Look, look at your C. This is your y-intercept. Your y-intercept is 7. And look at this first number right here is a positive. So it's going to be an upward parabola. Well, all of them are upward. So now let's see which one crosses the y-intercept at 7. So this crosses the y-axis at 4. This is 4. So it's not 7, so no. This one doesn't even look at it. It's way up here when it finally probably crosses, so no, it doesn't cross at 7. Okay, let's look at C. This crosses somewhere up here at probably 10, so no. And then let's look at D. This crosses, yes, this crosses at 7. So D is your answer. Any questions about how I get D is the answer? Okay, so now you can start using your calculator, and you will need it. So when you get your calculator, guys, keep in mind that since this is on the computer screen, the person that's in the classroom that's going to be with you, they're not going to know when you get to your calculator active part. You have to raise your hand and ask for a calculator. Inactive always comes first, okay? And as soon as the screen tells you to raise your hand to ask for a calculator, you need your calculator. That's why they put it in the calculator active section. Please don't try to do these without the calculator, okay? All right, so second plus 712. If something goes wrong with your calculator, you can ask for another one, or you can reset it yourself. It's second plus 7 and do all, you know, and that'll just reset it all together. If something goes wrong with your calculator, just reset it all together, or take the batteries out and replace and put them back in. Okay, if something goes wrong with it. Okay. All right, number 9. Any questions so far? Okay. All right, it's that time. I'm going to stop right here. I will make another video for your calculator active section, and then I'll post it for you. Are there any questions about the calculator inactive section? Okay. All right, I'm going to stop it here. If you have questions, please feel free to let me know.